Okay, so now for 2.6, we're going to be discussing what are called combinations of functions, and then finally composite functions. But for right now, let me talk about these main types of ways of combining functions. They're the main four operations we know and love with numbers: addition, subtraction, multiplication, and finally division. So we're going to be doing each of these operations with functions, and there are names for these functions. It sounds a little weird, but let me try to explain. So here, f plus g of x, f minus g of x, f times g of x, and f over g of x are all names for these functions. So this is the name, this is a name, this is a name, and this is a name. I know it looks like x distributes in here and x distributes here. You can think of it however you want, but just know that's not what's happening. F plus g is the name for adding the functions f and g together. Similarly, f over g of x is the name for adding, not adding, but dividing the functions in that order, f over g of x. The only restriction here with all these is that g of x can't be 0 for the division one, which I think is fairly obvious, because otherwise you have a 0 denominator. So now let's actually try to do an example. So here I say, given f of x is x squared plus 6 and g of x is radical 1 minus x, I want to find the following. So f minus g of x is, remember, it's f of x minus g of x. So what I'm going to do is do x squared plus 6 minus radical 1 minus x. And that's really it. Sometimes you may get some terms combine. In this case, nothing combines because of the radical, really. But if things combine, just combine like terms and box your answer. That's really all there is to it. So nothing too crazy happening here. For f times g of 1, there are two ways of doing this, actually. You can actually find f of g, or f times g of x, and then plug in 1. The better way of doing it, though, I think, is to realize that f times g of x is f of x times g of x. So namely, f times g of 1 is f of 1 times g of 1. So what's f of 1? Plug in 1. We get 1 squared plus 6 times what's g of 1? Plug in 1. You get radical 1 minus 1, which is 0. This is 7. 7 times 0 is 0, so the answer is 0. Great. Okay, now for the third part, f over g of x. Remember, that's f of x over g of x. And you do not want the denominator to be 0. So that's x squared plus 6 over radical 1 minus x. Now we do not want the bottom to be 0. So I'm going to box this. But here I've included domain. Now domain, I want to see when we have values of x that we can plug in and when we have values of x we can't plug in. So the biggest one is we can't make the bottom 0. We already saw from the second part here, g is 0 when x is 1, because you'll have 1 minus 1, that's 0. So x cannot be equal to 1. If x is equal to 1, then you'll have a 0 denominator. What else can x not be equal to? Well, remember, in order for this to be real, it can't be negative. When is it negative? When is the inside negative? The inside of the radical. So we want the inside of the radical, so let me just kind of bear with me for a second. Well, we want the inside of the radical, which is 1 minus x, to be positive. But we also don't want it to be equal to 0. Because if it was equal to 0, you'll get 0, which is fine for g of x, but it's not okay for f over g of x. So really we want 1 minus x to be greater than 0. If you solve this inequality, just add x to the other side, really. You get this. So our domain is really just the set of all x values such that x is less than 1. 1 bigger than x means x is less than 1. If you wanted to write this in interval notation, this would be negative infinity to negative 1. So this interval represents all x values that you can actually plug in that won't give you a 0 denominator or a negative in the radical. That's the most complicated it gets, really. And as far as the domain goes. But as far as these things go, all we're doing is adding, subtracting, multiplying, and dividing the functions just with x's like normal, and combine like terms if possible. Next, we're going to take a look at composite functions. It gets a little more crazy, but well, I guess we'll see right now. Okay, so now next for composite functions, we're going to take a look at what is called the composition operation. Now, the other operations we just saw earlier, addition, subtraction, multiplication, and division, can all be applied to numbers. Composition is a strange operation that is exclusive for functions. Cannot be applied to numbers. Okay, you can't compose two numbers. You can compose two functions though, and here's how you do it. So this open circle dot is the composition symbol, so that means compose, or I guess composed with. So the way we phrase this is f composed with g of x, and it is f of g of x. So you plug one into the other, in that order though. So the one first is the outside one, the one second is the inside one. Okay, so this is the only example we're really going to do. It's kind of a loaded question, so it'll take a little bit of time, but let's see if we can handle it. I know we can. So it says f of x is x squared, g of x is x minus 1, and we want to find the following four things. F composed with g of x, g composed with f of x, g composed with itself of x, and then f composed with g of negative 2. So that's an actual evaluation, but we'll see that shortly. So first, f of g of x. In fact, that's one way you can think of this open circle. Think of the open circle as an O in of, f of g. A lot of people will remember fog or goff. Don't do that. Just think of f of g, g of f. That's the best way of doing it. That's how I do it. So this is g of f of g. So f of g is what of what? Well, we're plugging g into f. So there are two ways of doing this. The best way is to replace all x's in f with g. So let's start from the inside out actually. So what is g? What is g of x? G of x in this case is x minus 1. So this is going to be f of x minus 1. Very good. But now what is f? F is x squared. So instead of writing x squared, I'm going to write something squared and replace that something with the inside of f. So x minus 1. So it's x minus 1 all squared. I'm going to actually expand this out. And if you expand this out and combine like terms, you'll get x squared minus 2x plus 1. So this is f of g of x. Okay, let's see if we can do the same thing for g of f, and hopefully it helps us understand this process a little better. So this is g of f of x. So we're going to start from the inside out. So what's f of x? F of x is x squared. So this is g of x squared. Now what does g say to do? G says x minus 1. So this is going to be equal to, these are all equal to each other. We're going to get x minus 1. But instead of writing x, it's something minus 1. What that something is whatever's inside of g. In this case, it's x squared. So we don't really need the parentheses. Our answer is really just x squared minus 1. Okay. Now g composed with itself is a little weird, but let's see. Keep the same idea in mind. So this is g of g of x. So what do? We work from the inside out. So what's g of x? G of x is x minus 1. So this is g of x minus 1. So we're plugging x minus 1 in for x in the g equation. G of x says x minus 1. So the outside g here is why I know to write g of x. So I'm going to evaluate g at x minus 1. So I'm going to write g of x, x minus 1, with a blank set of parentheses instead of x. So g of x is x minus 1, x minus 1. And again, these are all equal. Now instead of x minus 1, it's x minus 1 in those parentheses. So x minus 1, notice the negative 1's combine, and it's x minus 2 as our final result. Now again, I know it's a little disorientating, but you have to kind of think, what are we plugging into what? Here we're plugging x minus 1 into g. So write g, but instead of x, write x minus 1, whatever you're plugging in. So these are the same. Okay, that's the best way of thinking of it. All right, so now we're going to do the evaluation one. F of g of negative 2. There are two ways of doing this. One way is to think, well, we already know what f of g of x is, don't we? F of g of x was the first one. It was this. So all we need to do is plug in negative 2 into this. It's better to use the top one. I think it's quicker. Negative 2 minus 1 is negative 3. Negative 3 squared is positive 9. So you can do that. I'm also going to show you by just plugging it into the final result, even though I said it was more slow, just so you can see it. It's negative 2 squared minus 2 times negative 2 plus 1. Hope we all see how I'm getting that. I'm using f of g of x, our equation, and I'm plugging negative 2 in for x. And I get positive 4, double negative is positive 4, plus 1 is indeed 9. So that's one way of doing it, just plug it into the function we got. There is another way of doing it though. Or, the other way of doing it is to note that this is f of g of negative 2. So what's g of negative 2? Well, g of negative 2, remember g of x, what's g of x? G of x is x minus 1. So g of negative 2 is negative 2 minus 1, which is negative 3. Perfect. So g of negative 2 is negative 3. So this right here, remember we're working from the inside out. So g of negative 2 is negative 3. So this is really just f of negative 3. So now we ask, what's f of negative 3? So off to the side I'm going to do my work here. F of negative 3 is, well, f of x is x squared. So f of negative 3 is negative 3 all squared, which is indeed 9. So this is equal to f of negative 3, which is equal to 9. So we get 9 in a very similar manner. Well, I mean, it's not really similar. It's a little different. We're plugging it in one at a time, but it's nice. And in fact, I want to show you a nice diagram here for what's really happening. So in this case, we're getting the number negative 2. We're passing it through two functions. First, we're passing it through g. And when we take g of negative 2, we get negative 3 as a result. Then we're passing that through the f function. F of negative 3 is 9. So we get 9 as a result. So plugging these numbers into these functions gives us the resulting number. Remember, inputs and outputs, right? The input of negative 2 into g gives an output of negative 3. Negative 3 is an input for f, gives us an output of 9. And what does that do in total? It takes negative 2 to 9 via f composed with g. So there's a nice diagram there. We can just jump directly using the whole function, or we can go one at a time using g and f. But you have to go in that order. Inside out. Plug in g first, then plug in f. Okay, so that's really it for 2.6. And in the next section, 2.7, we're going to take a look at an application of composite functions, which is a really interesting one. We'll see that right now. And I'll see you in the next video. For that, thanks for watching. See you then.